Oh, hello, class. What's going on? Just getting some light in here for once. Here we go. Back in the old room. Where should this go? Let's go over here. Getting the webcam set up. How was everyone's Wednesday?
It's chill. How's yours?
My Wednesday was amazing, man. Thank you so much. I took my first nap, I think, in years.
That sounds great.
It was pretty nice. It was pretty nice. I haven't slept in years. No. Okay. Isn't that kind of awesome? Thank you very much. I love it too. There's also a beard below it. I thought that looked fun. But and by the way, that's not even the side of the room that's meant to be visible on Zoom. Let's just be facing the other way. It's my desk facing the wrong way. So this is the bad side. Just wait till you guys can see what's on the other side of this wall. And you'll get a vlog-worthy treat over here. I don't vlog, but I always want the option to. God, that was the webcam. Whoops. All right, so let's plug this baby. Online classes? Good? Bad? What are you guys thinking? The way JMU went, it's looking like we might be going there soon. You guys hear that news?
Yeah.
It's a talk show. Like, you hear about JMU? For a plug. Aha. I do this, and then I do this, and then we click this button to get this extra screen going. Nice. We are in for the day. Cool, cool. Well, welcome back, everybody, to Discrete Math Lecture 6. Yeah, Lecture 6. What's going on? We are now past a handful of lectures. So welcome. Welcome to the interior of the class. How's it going for people? Anyone have any questions, comments, concerns about the class? I should give out, you know what I'm going to do? I should give out like they always do it like Walmarts and stuff like that, where it's like, hey, if you fill out this survey on the receipt, you get 20% off your next thing. What if I make you guys fill out a survey and you get like 1 extra credit point? Ooh, that's better than 20% Walmart.
I'm down.
So the survey for if we should take a survey is looking good. It's just like those pre-trial trials. Just a bunch of things going in circles. Okay, so anyway, if no one has any questions, let's just get back to what we're talking about. We're gonna finish 2.2 today and then move on to 2.3. So let's get going with 2.2, the end. I think I've been saying the pages that this is like Karate Kid, the wax on, wax off, all that. If you haven't seen Karate Kid, I recommend watching it. Don't watch the Jackie Chan version. Watch the Ralph Macchio version. All right, but anyway. So to finish up section 2.2, remember this is about conditional statements. Which are the statements that have the structure if P, then Q, or another way to write that, because you can say P implies Q. That's a lot of times we write that. Or you can say, you can write it like that in the more mathematical notation. Or you could say, in my notation, if then PQ. I should tell you guys that like writing if then or like and then putting the P and Q there, or writing like the and or the or, PQ, all that kind of stuff, that is just for this class. That's just what I use to help you guys think. This is not necessarily standard mathematical notation. If you, oh wait, can you guys see that? If you wrote that, people might not know what you're talking about, but I think this is a good way to think about it, and that's why I do it. The point is, I'm recording this, so in the future, if this ever comes up and you guys are like working at Google or something like that, and this comes up, you cannot blame me. I will have this locked and loaded, this recording. Anyway, yeah, that's what conditional statements are. Now we're going to talk about a few statements. We're going to talk about today. What's a good color for today? Someone pick a color.
Purple.
I like it. That's the right answer. Then we're talking about inverse Converse, and Contrapositive. And this is just kind of like inverse converse contrapositive. Remember, this if then P, this P implies Q, this is a statement. So this arrow, and we got the focus thing again. But this arrow right here, this is an operation. And so inverse converse contrapositive, you can think of them as all different but related operations. You can think about them that way. But none of them are the negation. We talked about this last time. None of the negation. Whoa, that purple looks blue, doesn't it? I swear this is purple. Wait, look at blue next to it. Oh, they look the same. Interesting. Anyway, sorry. The point is that none of these are the negation. We were on the negation last time. Recall. Put this in the corner. Negation of P implies Q is, we can write it like this, and it equals P and Q or not P. If not P, you're vacuously true, but if P is true, then Q must also be true. That was the reasoning for this. Anyway, though, none of these are that. Inverse converse contrapositive is not the same thing as the negation. They are very different. So let's just go through it. The inverse of a conditional statement, P implies Q, I'm going to write it like that. That's just like what you'd say. What that is literally defined to be, I'll do like a little semicolon to let you know it's defined. Actually, I guess I have a triple colon because there's 3 equal signs. I don't know. It's literally defined to mean not P implies not Q. And then the converse of P implies Q, that's defined to be the statement Q implies P. And then the contrapositive of P implies Q, that's a weird one. Inverse and converse kind of makes sense. Like, oh, you can't see that. I'm sorry. Someone speak up next time. Inverse and converse, they're both in with verse. How'd you guys know what I was talking about? Verse, in fact. So, oh my God, they have inverse, but not the I. Anyway, the point is, yeah. So inverse kind of makes sense. Like you're inverting both P and Q. Converse, I don't know, it kind of sounds right? Like converse it kind of sounds like you're flipping things around. Contrapositive is the one that comes out of nowhere. Contrapositive sounds like it sounds like some kind of a snake from South Africa or something like that. I have no idea. It sounds like if you test positive for some sort of disease you get from a snake. That's what I think it is. Anyway, the point is, what this is going to be not Q implies not P. So the inverse, the converse, and the contrapositive of a conditional is itself another statement, but it's different. Or it looks different at least. I will tell you. Or let's just go through it. They look different. Do you think any of these is actually equivalent to our original statement? What do you guys think?
No.
Toru says no. Possibly. That's a much more measured answer. Right, that's good. See, I feel like, Toru, if you're going off of the tone I use to speak, because usually if someone says, do you think any of these are the same? The tone means no, but I'm terrible at acting. So the point is you cannot trust my intonation in the slightest. Sid is right, but in the worst way possible. Sid's vacuously right in a sense, because like he can never be wrong. Possibly, everything's possibly true. You know what I mean? Am I the sexiest man alive? Possibly. So Sid, are you want to take a better stand? Oh, sorry, was you said? I'm sorry. Who said possibly? I thought it was Sid. I saw his thing pop up.
That was me, Safa.
Safa. Okay, you got a better answer than possibly? Come on, take a stand with pride, Safa. You're like Aaron Burr here.
I mean, I say possibly because the only way to find out is, I guess, to do some truth tables, and I can't do all those in my head.
Exactly. That's a perfect way to think about it. The way to find out is doing some truth tables. But I will tell you right off the bat that Toru, you are 60% right, which in a certain sense is better than not answering. You know what I mean? And that is that the inverse and the converse are not the same. This is, and we're going to show why. This is not equivalent to P implies Q. This is not equivalent to P implies Q. These are very different statements. However, the converse, interestingly enough, if you both switch the order and flip and negate both sides, this is the same thing as P implies Q. But anyway, interestingly enough, this is a lot easier than this. Most people they come around to the fact that the contrapositive is equivalent to the original, but a lot of times we'll make this mistake and they say, oh, this means this or this means this. Do not make that mistake. Everyone here is better than that. And I dropped the one piece of paper I needed. Is my face really close to the camera? There we go. All right. So, what are we doing next? Oh, yay, examples. So, let's do some examples of this to kind of show what I'm talking about here. So, for example, let's say that P is the statement I went surfing, or I'll say I must have gone surfing. And then Q is the statement I must have gotten wet. Actually, I specifically made P red and make Q blue. There we go. So Q is now I must have gotten wet. So here's the question. Does P imply Q, first of all? If I go surfing, must I get wet?
Depends on how good you are.
That's actually a very, very good question. But must I get a little wet? In the face, maybe a little bit?
Probably.
From the ocean spray? Yeah. You know, the actual truth of this doesn't really matter. We're going to say it's true. You see what I'm saying is the point. And actually, since I said I here, right, you said depends how good I am not that great. So I will get wet. So yeah, if I go surfing, I will get wet. That is true. Can I? Yeah, cool. So now let's look at not P implies not Q, which is the inverse. So this is the inverse. I wrote inverse there. There we go. So is the inverse true? If not P is true, meaning if I did not go surfing, is it true that I did not get wet?
I'd say false.
False. Right? I cannot go surfing and still get wet. And still get wet. For example, if I take a shower, or for example, if I spill an entire glass of water on myself. Like, there's plenty of options on ways to get wet. That sounds weird. But anyway, the point is, yes, this is the inverse. If not P implies not Q, or not P does not necessarily imply not Q. So that's why I say it's false here. So even though P implies Q, not P does not imply not Q. That is false. And this is exactly why the inverse is different from the converse. This is the squares and the rectangles thing, right? Like any square is a rectangle, right? So if something's a square, you know it's a rectangle. But that doesn't mean if it's a rectangle, you know it's a square. That's exactly what this is. Now let's look at the converse. Actually, I'm sorry. That's the converse. This is saying if something's a square, you know it's a rectangle. If it's not a square, you don't know it's not a rectangle. That's it. It could just be a non-square rectangle. That might be more confusing than it's helpful. But anyway, I hope this example likes it. The point is you can't necessarily go in both directions, or you can't just necessarily negate both sides. It doesn't work like that. Those are the converse. Is it true that Q implies P? So is it true that if I must have gotten wet, then I must have gone surfing?
It's false.
Why is that false?
Cause like you said, yeah, you can get wet from other things.
Exactly. There's plenty of things. I could go running in a sprinkler and enjoy life. I could go running in the rain because life is so awesome. I could fall in a puddle. That's happened before. All these things are possibilities. You could be having a bad day and the car goes by and splashes a puddle of water on you having a worse day. Right? That could totally happen. So the point is, yeah. So the inverse and the converse are both not equivalent to the original. They mean different things because just because P implies Q, that doesn't mean you can go the other way. Just because P implies Q doesn't mean not P implies not Q. And notice we use the same exact logic here. Like, these things are actually saying the same thing in a weird way to look at it. And we're actually going to show later that the inverse and the converse are themselves equivalent, but they're both not equivalent to the conditional, the original statement, or the contrapositive. So, this is an example of, where's my watch button going? Paper towel. So this is an example of how the original statement is not equal the conditional. Any questions? All right. Let's look at another example real quick. Let's look at an example. Let's say P is pigs fly, and then Q is, what, does anyone know what a quail is? Do quails fly? Is there a bird such as the Q? Oh well. We're gonna lose the alliteration.
Quails do in fact fly.
Quails do fly? All right. Quails fly. Look at that alliteration. Isn't that nice? This is the above and beyond that I put in this class for you guys. It's the alliteration. Yeah, so pigs fly. So pigs fly, quails fly. So here's a question. Does P imply Q? Right now it's a question mark, but hopefully not for long.
Probably false.
So I totally get what you're coming at. And you could definitely make that up.
Just kidding. Is it vacuously true?
Vacuously
Yep.
true. Yeah. We're saying if pigs fly, then quails fly. Well, I mean, remember, that's a conditional statement. That is just telling you if P happens, it's telling you something about Q. But P doesn't happen, so it's not really saying anything, and so we say it's vacuously true. So this is true vacuously. This is just, remember, this is just because the truth table looks like this. True, false, true. Oh, no. True, 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 false, false, true, false, false, true, false, true, true. We're in this condition here, right? But like whenever the hypothesis P is false, oh, you guys can see that. Whenever the hypothesis is false, we consider it true vacuously. We talked about that last time. Okay, P implies Q is vacuously true. So in our sense of the word, in our sense of if then, if pigs fly, then quails fly. That's a true statement because pigs don't fly. Now, how about this? How about does not P imply not Q? So what's that saying? That's saying if pigs don't fly, then quails don't fly. Is that true?
No,
False. Exactly.
because it's the inverse.
Because it's the inverse. And the inverse is not necessarily the same. We'll do an example. What is the same? Is that, well, I'll show you. We'll get to that in a second. So the inverse is not necessarily the same. So we've done an example where, yeah. So we get false there, and then we get P implies Q. I'm sorry. We get Q implies P. Q implies P. That's saying.
Can't quite see that.
Oh, thank you very much. I'm glad that you trust me enough to know that I'm not just losing my mind and scribbling on the ground. There we go. Good. You know I'm actually right. Good. So Q implies P. Is that true or false? So if
Also false.
then do pigs fly? Oh, sorry, I didn't hear that. Say it again.
Also false.
Also false. Exactly, right? And once again, they're false for kind of the same reason. The problem here is that, so here we're saying that if pigs don't fly, then quails don't fly. The big problem is that, well, quails do fly. You know what I mean? So that's not true. And here, quails do fly, pigs don't fly, so it's false. So anyway, it's going to turn out that the inverse and the converse are always equivalent to each other. But okay, gonna stop recording.